So we decided to do the third experiment, the single displacement. To begin the experiment, we grab a 150 milliliter Erlenmeyer flask and add it to the workbench. We then add 15 milliliters of 6 molar hydrochloric acid, and then we have to double click the Erlenmeyer flask to be able to close it. We need to close it because the reaction produces a gas. Then we take the thermometer and the pressure gauge and we connect them to the Erlenmeyer flask. We then have to add 0.25 grams of zinc to the Erlenmeyer flask. When we make the reaction occur, we see bubbles are produced and the temperature increases to 26.3 degrees Celsius and the pressure increases to 1.71 atmospheres. Now we have to let the reaction sit until it drops to right about 22 degrees Celsius. So in the meantime, we're going to look at the balanced chemical equation. In the equation, we see that we begin with zinc and hydrochloric acid and produce H2 and zinc chloride. Since it's a single displacement, we see that the zinc changes places with the hydrogen and produces hydrogen gas, which is H2, and zinc chloride. To balance the equation, we needed to have 1 mole of zinc for every 2 moles of hydrogen chloride, of HCl, and we produce 1 mole of H2 and 1 mole of zinc chloride. While we wait for the temperature to drop, we're going to perform the alternative experiment in which we follow the same procedure, but we add 25 grams of zinc instead of adding 0.25 and see what happens. So we add the 15 milliliters of HCl, we close the Erlenmeyer flask, we then add a pressure gauge and a thermometer, and we add 25 grams of zinc. When we do that, we see that the glass breaks, and so we now have to wait for the temperature to drop to 22 degrees Celsius. When the temperature drops, we will follow the last 2 steps of the procedure, which is to add a syringe, and that way we can measure how much H2 is actually produced, and it will also drop the pressure back down to 1 atmosphere. We will then record all the values, including the amount of gas produced, and dispose of the rest of the materials. Now that the temperature has dropped, we're going to add the syringe, record that we produce 92.6 milliliters of H2 gas, and the atmosphere has actually dropped back down to 1. We now dispose of all the materials and record our data.